Alright, today we're going to go over page 132, 1, 2 to 18 even. This is the 2.6 homework, part 1. Alright, number 1 is a vocab question. Just says copy and complete. If a polynomial function has integer coefficients, then every rational zero of the function has the form p over q, where p is the factors of the last term, and sometimes we call that the constant. Q is the factors of the leading coefficient. And sometimes we say that's the first number you see. Okay. Remember, this is all when it's in standard form, so you must have standard form. Number 2 just says describe a method to limit the list of possible zeros when you use the rational zero theorem. Let's talk about when you find your p's and your q's. And really the best way to do it is to sketch a graph of the function and use the x-intercepts. That's it. Alright, so number 4, we have g of x equals x cubed minus 4x squared plus x minus 10. Now remember, we first have to find p and q. P is our last number, q is the first number, so technically there's a 1 there, so that's our q. So I have p is 10, q is 1. So then I have to list the factors. How do I get 10? Well, 1 and 10, and 2 and 5. Remember, we gotta take into account the negatives too, so we put plus or minus in front of everything. And how do I get 1? Well, 1 and 1. But really, I don't need that second one because it's just a repeat. And then finally, I put all the numbers in the p list over all the numbers in the q list. So I just say p over q. I have plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10, and they're all over 1 because that's the only number on this list. Okay? And that's it. So this is your final answer right here. And you don't even have to write over the over 1 if you didn't want to. That's optional. All right, moving on. Alright, number 6, we have 2x cubed plus x squared minus x minus 18. Well, p is negative 18. So how do I get negative 18? Well, I could have plus or minus 1 and plus or minus 18. I could have plus or minus 2, plus or minus 9, plus or minus 3, plus or minus 6. Now I have to find my q. Well, how do I find q? Well, it's the first number I see right there, so that's q. And how do I get 2? Well, I have plus or minus 1 and plus or minus 2. So now, I do my p all over my q's, and I get my list of numbers. So I write plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18, and I put it all over 1. Then I go again, I do everything again, I go write all my p's again, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18, this time all over 2. Now the big thing that you guys want to remember is that if anything can be simplified, it's almost always a repeat. I can't actually think of a case where it's not. So right here, I have 2 over 2. 2 over 2 right here is the same thing as 1 over 1, so I cross it off. It can be simplified. 6 over 2 is equal to 3, which I already have right there, so I cross it off. 18 over 2 is equal to 9, which is right there, so I cross that off. So that's my final answer right here. Moving on. Alright, number 8, I have 3x to the 4th plus 5x cubed minus 3x plus 42. I find my p's and q's. Well, 42 is my p. That's going to give me 1 plus or minus 1 plus or minus 42 plus or minus 2 plus or minus 21 plus or minus 3 plus or minus 14 plus or minus 6 plus or minus 7. My q is 3. So that means I have plus or minus 1 plus or minus 3. So when I do my p's over my q's, I write them all once, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 7, plus or minus 14, plus or minus 21, plus or minus 42. And I do them all over 1, which means I just leave them exactly the same. I'm not even going to write the fraction bar this time, because you don't have to if it's over 1. Because anything over 1 is itself. Then, I write them all again, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, and keep on going. And this time, I'm going to put them all over 3. Alright? And once that happens, you just have to go through and find any repeats. Like 3 over 3 is the same thing as 1, so I cross that off. 6 over 3 is the same thing as 2, cross it off. 21 over 3 is 7. 42 over 3 is 14. And so there's your final answer right here. And that's it for 8. Alright, number 10, we have 6x cubed minus 3x squared plus 12. 12 is going to be p. So it's going to tell me plus or minus 1, plus or minus 12, plus or minus 3, plus or minus 4, plus or minus 2, plus or minus 6. 6 is q. So that's going to be plus or minus 1, plus or minus 6, plus or minus 2, plus or minus 3. Now I'm going to put all my p's over all my q's. Say plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, minus 6, plus or minus 12. Write them all once, and then I write plus or minus 1, plus or minus 2, plus or minus 3, plus 4, plus or minus 6, plus or minus 12. Put them all over 6. And now I'm going to cross off the repeats. 2 sixths, 6 over 6, 12 over 6, 3 over 6 can be simplified, 4 over 6 can be simplified. So that's my final answer. That's it for 10. Alright, 12 through 18, you're going to start the same way you did on 4 through 10. So you're going to start with the same steps as 4 through 10 to begin. Then you're going to divide using synthetic division. Remember, that's the box right there where you pick a number on the outside. Alright? So that's what we're going to do. Alright, 12. Once again, we're going to find p and q. There's my p. There's no number there, so that makes my q 1. And that means my p over q is just all the factors of 56. So 1 in 56, 2 in 28, 4 in 14, and then 7 and 8. Right? So remember, because the only way to get 1 is 1 and 1. The only way to get 1 is 1 and 1. Everything's going to be over 1, or everything's just going to be just the p. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 7, plus or minus 8, plus or minus 14, plus or minus 28, plus or minus 56. Now remember, when I do my synthetic division, I just always start from left to right. So I put 1 outside the box first. Remember, these numbers right here give me inside the box, so that's why I have 1, negative 5, negative 22, and 56. We're going to try with 1. I put 1 down. 1 times 1 is 1. Get negative 4. 1 times negative 4 is negative 4. So I get negative 26. 1 times negative 26 is minus 26. And that's 30. Since that has a remainder, it tells me 1 doesn't work. Right? So I can try again. So I'm putting negative 1 on the outside. 1, negative 5, negative 22, 56. I put 1. 1 times negative 1 is negative 1. I get negative 6, positive 6, negative 16, positive 16, 72 is my remainder. That doesn't work either. Right? Do the same thing again. Now I'm going to pick 2. 1, negative 5, negative 22, and 56. Put 1 here. Remember, you multiply on the outside, so 2 times 1 is 2. You add on the inside, so negative 5 and 2 is negative 3. 2 times negative 3 is negative 6. I add to get negative 28. Gives me minus 56. Now I have a remainder of 0. Once I have that remainder of 0, that tells me this is a solution. And because this was x cubed, my new answer is x squared, which I get from here, minus 3x, which I get from right here, and minus 28, which I get from right here. I break this down into x minus 7, x plus 4. So remember, minus 28 can be minus 1 and positive 28, minus 2 and 14, or minus 3 and minus 4, positive 7. Well, minus 4 and positive 7 gives me a plus 3 in the middle, so I switch the signs to get this. Now remember, you're going to set this equal to 0. Alright? Then once you set that equal to 0, you get to say, once you set x squared minus 3x minus 20 equal to 0, you factored it like we just did, you get to set each set of parentheses equal to 0. So then I get x is equal to 7 when I add 7 to both sides, and then x is equal to negative 4 when I subtract from 4 sides. There's one more solution. I have x is equal to 2, because if I look back, this whole thing right here tells me my last solution. Okay? So 3 solutions. 3 solutions are zeros. Moving on. Alrighty, 14. Exact same problem as 12. We're going to go through the whole thing. I have to find the p, which is 72. How do I get 72? Well, I could have 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, and 8 and 9. Now remember, my p's over my q's, because this is 1 here for my q, are just all these numbers right here. So my plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8. And then plus or minus 9, plus or minus 12, plus or minus 18, plus or minus 24, plus or minus 36, plus or minus 72. Alright, now we're going to start doing our synthetic division. So make my box. I'm going to put 1 on the outside. 1, 8, negative 9, and negative 72 go on the inside. Drop down the 1. 1 times 1 is 1. 8 and 1 is 9. 1 times 9 is 9. 0. 1 times 0 is 0. So I still get, even though that 0 showed up, I still get a remainder of 72. Alright? Now, I don't like drawing, in the last one I drew new boxes every time. I don't like doing that. I usually keep one box for each number I check. So if I check 1, I keep that same box when I check negative 1. So now I'm just going to change that to a negative. 1 drops down. Negative 1 makes it 7. Negative 1 times 7 is negative 7. I get negative 16, which makes it positive 16. And then I end up with a remainder of 56. Negative. See, I got a remainder. It tells me 1's not going to work. Boom. Cross it off. Moving on to 2. 2. 1, 8, negative 9, negative 72. Drop down. 1 times 2 is 2. 10. 2 times 10 is 20. Get 11. 2 times 11 is 22. I end up with negative 50. Not good. All right, so I'm going to change that to a negative 2. If I change that to a negative 2, that makes that negative 2, which makes that 6. And like I said, I don't like making a new box every time I do it. Just change the sign. I'll usually only make a new box when I change the number. So it makes that 6, makes it negative 12, negative 21, makes it positive 42, which gives me negative 30. Notice I'm getting closer. I wasn't getting much closer when I picked the positive number. When I picked the negative number, I was getting closer to making that, because I know I want this number to be positive 72. So when I make my next box, I'm going to try negative 3 first, not positive 3. So I tried that. And I'm going to just see if it works. 1, 8, negative 9, negative 72. Negative 3 times 1 is negative 3. Get 5. Get negative 15, which is negative 24, which is positive 72, which means I have no remainder. Which means that's a solution. So I know my answer is going to be x is equal to negative 3. Now I make my new equation, my new expression is x squared plus 5x minus 24. Well, I know I can get 24 by 1 and 24, 2 and 12, 8 and 3. If I make them one of those negative, I could get 5 with negative 8 and 3, but I want to get positive 5, so it has to be positive 8 and negative 3, which means I have x plus 8, x minus 3. I set them both equal to 0, so I get x plus 8 equals 0, x minus 3 equals 0, so x is equal to negative 8, there's my second 0, x is equal to 3, that's my last 0. Remember, I knew the degree could tell me that there's at most 3 zeros. And there was. There's not always going to be 3 zeros. That's what we're going to see what happens in the next two problems, 16 and 18. Alright, 16. Because it's to the 4th power, I think right away I'm going to have to do synthetic division twice. Because my goal is to eventually get something to the 2nd power. When I do division once, it's going to take me something to the 3rd power. But let's see what happens. So once again, I find my p is negative 24. So plus or minus 1, plus or minus 24, plus or minus 2, plus or minus 12, plus or minus 3, plus or minus 8, plus or minus 4, plus or minus 6. Since q is 1, remember that's my q, I don't have to worry about those fractions, but I could if I wanted to. So my p over q is just plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. Alright, now I make my box. I'm going to put one out, I'm going to put 1 outside the box. 1, negative 2, negative 9, 10, negative 24. Drop it down, I get 1. 1 times 1 is 1. 2 and 1 is 3. 1 times 3 is 3. Negative 6, negative 6, positive 4. 1 times 4 is 4. That's going to give me a remainder, not going to help me. So I tried 1. Now, I'm just erasing, and I'm going to try negative 1. Negative 1 gives me negative 3, positive 3, which gives me negative 6, positive 6, 16. Close. But it's negative 16 there. So that's not going to help me. So now, I'm going to try 2. So I'm going to put 2 outside the box. And just go through again. So put 2 outside the box. 2 times 1 is 2. I get 0. 2 times 0 is 0. I get negative 9, negative 18, negative 8, negative 16. Doesn't work. You get a remainder of, I'm going to have a negative remainder. So now I try negative 2. So I get negative 2, negative 4, I get positive 8, negative 1, 2, 12, negative 24, which gives me negative 48. Even though they match, remember they're going to be opposite signs. So 2 is not going to work. So now I'm going to try 3. Make it positive 3. I try 3. Get 1. 1 times 3 is 3. Get negative 6. 3 and negative 6 is negative 18. 10 and negative 18 is negative 8. And I get negative 24 again. Once again, that's a remainder of negative 48. Not going to help me. Alright, so 3 didn't work. Now I'm going to try negative 3. Drop it down. Negative 3 times 1 is negative 3. I add to get negative 5. Gives me positive 15, which gives me 6, which gives me negative 18, which gives me negative 8, which gives me my remainder of positive 24, which means this works. Now the issue that shows up is this is now x cubed. It's not x squared anymore. So minus 5x squared plus 6x minus 8. So I have to redo the whole problem again. I have to do synthetic, I have to divide again. So I have to find a new p and a new q and divide everything again. So that's my p. My q is 1. So my p is plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And I put it over my q, so everything's over 1. Right? So on the next page, I'm just going to divide this. And what we're going to have inside the box is 1, negative 5, 6, and negative 8. Alright, and now remember, so I just want to do a new page. Remember on the last section, we already tried 1 and 2. Those are already gone. So I don't have to worry about trying those again when I found my new P's and Q's, because this is still in essence the same problem. I don't know why I have a 6 there, there. So the first thing I'm going to try is 4. Drop down the 1. 1 times 4 is 4. Get a negative 1. Get a negative 4. Get a 2. 4 times 2 is 8. Boom, there's my remainder. No remainder, I mean. Which means I now have x squared minus x plus 2. Now here's the issue. The only way to get 2 is 2 and 1 or negative 2 and negative 1. And neither one of those will give me negative 1. So neither one of those will work. Which means this is unfactorable. Alright? Since it's unfactorable, I have to use the quadratic formula. So A is 1, B is negative 1, C is 2, X is equal to the opposite of B, plus or minus the square root of B squared minus 4AC, all over 2A. Put 1 in there, 1 here, and 2. When I end up with X is equal to 1 plus or minus the square root of negative 7 all over 2, that negative 7 turns into an I. So these are not real answers. So I don't even need them. So my only two answers are X is 4, and from the previous page, X is negative 3. So there's only two answers. X is equal to negative 3. X is equal to 4. And that finishes this problem. Alright, 18. I'm going to find my P. It's 25, so I have plus or minus 1, plus or minus 25, plus or minus 5, and that's it. I don't have to write the 5 a second time because I don't need repeats. Q is 1, so my P over my Q's is just plus or minus 1, plus or minus 5, plus or minus 25. Make my box. 1, negative 16, negative 40, minus 25. I'm going to put 1 on the outside of the box. 1 and 1 is 1. I get negative 15. Negative 15 is negative 55. That's going to give me a negative remainder. So now I try negative 1. So now I'm trying negative 1. 1 and negative 1 is negative 1. I get positive. That should have been, last problem should have been 17. I wouldn't have changed it. It's still no remainder for 1. Negative 1 and negative 17. Oh, I didn't miss a lesson. Okay. Positive 17. Negative 1 times negative 17 is positive 17. That gives me negative 23, which becomes positive 23, which gives me a remainder of negative 2. So 1's not going to help me. Let's try 5 on the outside. 1 minus 16, minus 40, minus 25. 1 and 5 is 5. Negative 11, minus 55, minus 95. That's going to be a big negative number. Minus 480. 490, no, 40, which is going to give me a big remainder of negative 505. So positive 5 is not going to work. Let's try negative 5. Try negative 5. Negative 5 minus 21 becomes positive 105, becomes 65, becomes negative 325, which is going to give me negative 350 as a remainder. 5 is not going to work. So now I'm going to go again. I try 25. I try 25 and I notice I'm going to get a really gigantic negative number. That's not going to work. So then I try negative 25. When I do negative 25, I'm already getting into the thousands, so that's not going to work. So I tried all my numbers, which tells me. So once I try all the numbers and it doesn't work, it tells me there's no solution. Or at least with real numbers. So that's it.